you, Asama-san. Then now, okay, welcome to my presentation on understanding AI for story generation. So basically, it'll be the basic agenda is first I will talk about my guesses for what story generation is, what the AI research for story generation might be going the direction of before I read the papers, and also prior approaches. By prior approaches, I mean techniques before GPT-4 was introduced, since I noticed that a lot of things changed after that. After that, I will talk about a paper called Globe, which is pretty interesting, and I will tackle two questions. Can LLMs write good stories to begin with? And also, can LLMs actually understand the complexities of stories? And finally, I will just talk about two two approaches of first generating a plot, and also talk about making a story foundational model, which is another interesting paper. Any questions? So first of all, I will talk about the three guesses I had going into this literature review. So my first guess was there's a famous game called Dwarf Fortress, and also there's a lot of good story games where they kind of generate a story as you play along, and the main idea behind it is you do a simulation. In this case, the game generates an entire history of how dwarves, humans, and elves and stuff interact, and you kind of just go inside the middle of that. And I thought that would be an interesting approach, but the main limitation I can think of here is that it restricts what kind of stories you can make. So in this game's case, you can only make stories about dwarves and elves and humans and stuff. Another approach I was thinking of is, what about having a good story classifier? So a popular approach for image generation is GANs, where you have a generator generate an image, and a discriminator saying oh, that image is good or bad. So I think a good approach will have been to kind of given a story, there's plenty of amateur stories out online, classify whether it's a good or bad story, and then have a generator try to optimize that. And currently, I don't think that is done yet because, for example, this is a famous Japanese site where most of the light novels and anime are produced from. And here kind of basically they try to find whether a story is good or bad based on popularity and how many people view that story, which mainly led to optimizations for the writers to make longer titles so that people click on it more, and also make the beginning plots the most intriguing, basically making a great premise and not the story itself. So yeah, kind of currently I think that's a bit lacking department, but also there is a question of what is actually a good story, which is a very subjective question. The final guess I had was a bit similar to the Dwarf Fortress idea, but why don't we just take inspiration and look at all the history that humans have had and just kind of use an LLM somehow to make a story about some single character in that history, which I think is what a lot of classic works are doing anyway. For example, Flowers for Algernon. Okay, I try restarting Discord, and I think your audio might come back. Okay, so now given all that, what's the research like? How are stories actually generated using AI? So I started off with a Globe paper, and they mainly mentioned two approaches on how stories are generated before GPT-4. So the first approach is a pretty interesting approach, where the idea is like, let's have all the like lines of the stories going up to the ending, and let's try to make the AI just generate the ending. And the reason they did this was they assumed that if they did this, it'll force the AI to understand what the story actually is talking about. So in this case, like today's Halloween and all this, so the ending is like Jack wants to get a lot of candy. And the way they did this is a bit complicated, but the basic gist of it is given like all the previous information, and also like given like the words like Halloween and stuff. So they try to kind of like get like it's a bit like RAG, where they try to get like words that are similar to Halloween and stuff, and encode that meaning using like a bit of like a graph-like approach that I talked about in the last presentation. And then basically kind of given all those like similar words to each word, and also like all the previous context, they just try to generate the final sentence. So that is like one approach. It's like trying to generate an ending. Yeah, any questions? Okay. So another approach is given an outline of a story, why don't we try to make an LLM generate like each sentence in the story? So for example, in this case, it's like given like the need of love and the emotion of joy, it generates each sentence like this. And kind of like, this is, I think you can see that this can actually, I guess it can generate a story if you kind of like tell it every single step of like how to make it. But yeah, it requires like a lot of human control for like good story results. Or like in this paper, it says explicitly that kind of like it's very hard to make stories which have both complex and creative plots. And like for existing methods, they try to like make it complex by putting in a lot of like human intervention into it, which kind of like restricts the creativity. So yeah, now we finally get to the main gist of this GROVE retrieval augmented complex story generation paper. And this paper mainly has 3 parts to it. Anyway, questions until now? Okay. So the first part is the retrieval repository. And firstly, they get a dataset called writing prompts, which is a very large dataset of 300k like human written stories with like the prompts of the story. So like write a story about this and you write a story. And then the authors kind of extracted something they called conditions from the story, like mood and genre and like characters and stuff. And then, so now we have like a pair of like let's say the mood to the story. And then basically we want to input target conditions, like saying like, I want the genre of science fiction with like a sad mood or something. And then it'll find like the most relevant stories based on like a RAG of doing like matching like finding the most similar conditions to get like finding the stories with the most similar conditions in this retrieval repository, basically. The second thing that they did is they made something called evidence forest construction by asking why. So, okay, so now that we have this retrieval repository, we have this target condition, we have this kind of like type of story we want to generate. We first retrieve like similar stories from the retrieval repository. Then we use this like just put it in the context to generate the initial story. But now, kind of like, as we said before, kind of like if we do this, the story might be creative, but it might lack complexity. So what they did now is they have a LLM kind of like find all the ambiguities in this initial story. So now we have like a single, and then we are making like a tree. And basically the idea is, given this ambiguity as the root of the tree, that we recursively ask the LLM what the solution to that ambiguity is. So let's say that it's unclear why this character kind of like suddenly jumped in the story or something. And we kind of like get answers like, oh, in like his background history, he kind of like was taught by his father to always jump when a certain something happens or something like that. So we just keep recursively asking like, what's the, oh yeah, is that a question? Interesting. I'm not sure about why this is, but so I guess it's like different approaches, right? So like for ending kind of based approaches, I'm assuming you mean ending versus like outline based approaches. For ending based approaches, it's mainly like you can only generate the ending, but for like outline based approaches, it's like making the entire story kind of based on like an outline. So it's like a different way of generating stories in general, I think, if that makes sense. Yeah. So yeah, now kind of like basically what this evidence forest thing does is it finds all the ambiguities and it finds all like the plausible solutions to it, basically. And one thing to note is that each of these solutions by themselves might contradict each other. So only like one, and kind of like even giving a solution, a new ambiguity might arise. So basically we recursively keep asking like whether this solves all the ambiguities in the story, and then we keep kind of like generating solutions for that. So it is recursive, kind of. So we basically get like a tree, not just this like a one layer tree. Okay, any questions here? Okay, so now, given all these change, like by change I mean like ambiguity, solution 1, let's say solution 2, solution 3, and so on. Given all these chains, basically what the LLM does is it finds like the most plausible chain in this tree for like resolving all the ambiguities. So let's say there's like 10 ambiguities in the story. For each ambiguity, we get a chain. So we have like 10 chains here. And now, given those chains, we kind of rewrite the story. And like the overall diagram is like this. So we have the LLM generate the initial story, and then given this, we kind of like we kind of figure out all the ambiguities and like find like the right chain, and then we use that to kind of generate the story. And here's like the retrieval result. Yeah, sorry, that was a bit complex, but is there any questions? Okay. So now, kind of like one question I had was, so we basically initially get the story from the retrieval repository in like the course of like generating this story, right? So my question was, isn't it just like copy pasting this story into the initial story, so that isn't that the reason like we get like good stories? And the answer is no. And how we know this is we couldn't find like any. Basically, I think the authors actually like sent the stories to like plagiarism checkers and stuff, but they couldn't find any evidence of it. And also they did something called aberration studies, where they look at the performance of it without like each part. And one part I want to highlight is like, for that retrieval thing, it does help a bit, but overall, like, even if we like remove it, it doesn't like affect the performance too much. At least from my perspective. So overall, like, the retrieval thing, while it's there, it doesn't lead to plagiarism per se, and also like it doesn't help like too much in like in I think this story generation thing. And for how good it is, kind of like they basically did like a lot of comparisons between like humans versus in context learning chain of thoughts and stuff. They noticed that their technique outperforms humans and stuff. And this is like with human evaluation. So human, like people with like master's English majors and stuff, thought that the stories generated by this AI was better than humans. So now the question is, well, one obvious limitation is that these stories only fit within the GPT-4 context length. But like another more like interesting kind of like idea is like now that we have this, can like this just generate like any kind of story ever? Like do we no longer need like Stephen King or like Neil Gaiman, those kind of all those great authors? Can we just kind of like have GPT-4 generate all the stories for us? So I really wanted to highlight like two assumptions that this paper makes, and that the first one is it's assuming that the main thing that is lacking from LLMs is complexity, and in that like in just like writing stories that are like not complex, like for just writing stories by themselves, LLMs are fine. But once it becomes complex, it has a hard time. That was like one assumption I think I found in a paper. And also another thing is that in this kind of like chain of evidence thing over here, I think there's an assumption that LLMs are capable of like making like a good complex plot just from like recursively asking itself. So another question is like, is that true? Like, can we like make like a Stephen King like novel just from LLMs asking itself why for like each detective plot? So yeah, that is the main assumptions I got from the paper. Oh, welcome. Wait, can I not? Okay, sorry. So yeah, I don't think I have. Are you invited to speak now? Okay, welcome.
Yeah. Yeah, Isamu. Regarding the chains that you were talking about,
Yeah.
like what's the approach that they've taken to choose, like, since it's kind of subjective, like which chain is the most plausible amongst the chains that have been generated?
Yeah, great question. Basically, the answer is they just ask a LLM what's the best chain.
Oh, okay. Thanks.
Yeah, no worries. So, yeah. So now that we found the assumptions, let's try to like evaluate them. So, first of all, can like LLMs write good stories in like all aspects other than complexity? And the first paper that says this isn't true technically is this paper called Creating Suspenseful Stories, Iterative Planning with Large Language Models. And basically the idea is that paper authors found that at least with human evaluation, that current LLMs are not good with like generating plots that have suspense. And like the reason for this is that they raise is that for suspense, there must be like a protagonist that is like empathetic to the reader. The protagonist must kind of like face like a high possibility of like reaching like an undesired outcome. And like the kind of like many those do. Basically what the authors focused on was the protagonist kind of like tries to do like a certain action to reach a goal, and like he keeps kind of getting pushback to kind of like making his odds of like succeeding more and more like unlikely. That's how the authors can define like suspense. So they came up with a solution to this, where like basically we have like the protagonist kind of trying to reach a goal, and then it says like how he tried to reach a goal, and then they ask the LLM, given what he tried to do, like he failed to achieve this, and why is that? And then basically we have this antagonist LLM trying to like fight back against it, and then next we ask the like, LLM again, like, oh, so you tried to do this, but you failed because of this. What do you do now? And you just keep going on forever like that. So technically, yeah, this kind of like solves this suspense problem. But another thing that the authors, different authors noticed is that LLMs kind of like when it try to generate stories, it lacks kind of like proper pacing. So like for example, it can kind of like jump from like something that is ambiguous in the story to like suddenly like some kind of new plot in a way that is a bit jarring. So basically what the authors did for here is given like an outline of the story, they kept expanding every part that was vague, which they kind of like made a classifier for. So they find every part that is vague, and then a bit like Globe, they kind of like expand on all those vague parts to make like to make like more like events in the outline so that it's a bit less jarring to read for the outline of the story. And then after that they generate the story. So that is how they kind of solved it. But one thing I wanted to highlight is these authors were able to like find like flaws in having an LLM write stories by itself, and they had to kind of like create like their own like prompting strategies and such to overcome it. So I think one kind of like reasonable conclusion is that the LLMs kind of like by themselves do not have like all the elements of like writing a creative story by itself, like even without much complexity. Yeah, any questions? Thank you. Oh, thank you. Yeah, hope it's easy to answer. Oh, welcome.
Hey, can you hear me?
Yeah, I can hear you.
Awesome. Yeah, this is actually a really cool piece. I had no idea that we had this idea of chains being used to help. And this got where the question's going. What other advancements here? Because this is an LLM, right?
Yeah.
Do you have any multimodal models that are currently trying to see if there are other ways that we can communicate a story, such as something complex? Oh yeah, go on, please.
No, great question. I didn't cover multimodal stories in this presentation, but yeah, there is definitely some. And for like where to find them, there's like this is the repository where I got all the papers from, and I think there were like some pretty interesting one like this, like let storytelling tell vivid stories and expression influence with multimodal thing. And I think yeah, you're talking about like comic book stories and stuff, right? Like yeah, right.
I guess only given that, when we try to encode something like, let's say, suspense, there could be, even if you gave, let's say, an AI 3 or 4 weights or rules to, this is the outcomes for a suspense story, you can see that, without certain contexts, such as maybe the description of the environment or the imagery that we usually come up with when we think of how we generate stories as human beings. I'm curious if there was a multimodal model that accepted inputs such as, this is a visualization of the scene. This way we get closer and closer to generating something that's closer to a ground truth, like a retelling of Mary Shelley's Frankenstein. But that's where I was, because a GAN model works great for music or comparing even generation of photos, but stories and language specifically, I feel like there's some nuance there that might be difficult to just put into one certain language, even if it's a large database like an LLM can go through. But I'm curious to hear your opinion on that point.
Yeah, that's a great point. And I've heard this point kind of from people who talk about AGI too. Let's say there's a chair. You can't kind of encode everything about the chair into natural language that you can see visually. It's just an impossibility. You can only kind of show a certain perspective into language. But yeah, kind of to your point, I agree, but I don't see much research of trying to make, at least from what I viewed, I couldn't find much research on trying to expand the knowledge of LLMs for stories using images too. For example, for GPT-4o and those stuff, I know in Gemini and stuff, there seems to be a focus on multimodal LLMs to make it smarter and stuff, but I haven't seen anything that is story specific yet. Yeah. Does that answer?
Thank you so much. Yeah, that's it.
Okay, yeah, but let me get back to you. Maybe I will DM you a paper if I can find one. Something, yeah. Okay, yeah, any other questions? Okay, then yeah, let me get back to this. So now let's tackle the other assumption. Can LLMs generate complex plots? And now we'll get to my favorite paper in this presentation, which is Large Language Models for Short, Understanding Complex Relationships in Detective Novels. So basically what the authors found was that LLMs are basically incapable of understanding complex relationships for detective novels and stuff. Here this person wants to murder one of the people to marry the brother or something, but she accidentally murdered the wrong person or something. So yeah, so first of all the authors found that evaluating that it's hard to kind of evaluating how good LLMs are with complex relationships is hard in the current world. And the reason is, for classic stories, Shakespeare and stuff like that, are all in Project Gutenberg, so the LLMs are already trained on it. So when asked about relationships, it already knows the answer without even knowing without even prompting it with the story. And another reason is most data sets apparently are children's stories when evaluating stories. So when we kind of introduce a character, we don't just have there is no mystery there. The character is introduced in its totality when they are introduced, and there's no change from that. They are not aliases or incomplete and uncertain information, and there are no contradiction, which kind of arises from let's say one character dying to another character. So what the authors proposed was a new evaluation benchmark called Conan, which yeah, I think it's a very clever name, which stands for Contextual Narrative Analysis. And the basic idea is, for the input, you have a narrative of K characters. So these are the K characters. And all of them will have the narrative and also a background story. And now there are 3 tasks. First of all, it's the extracting all the characters from all these stories. next, we want to link all the characters, a bit like a graph, of like of like each of them kind of like has like a perspective of what their relationship is like with everybody else. So like basically making that like a graph of like relationships. And finally, we want to like infer like hidden relationships, like, oh, this person is the murderer of this person. Yeah. Any questions so far? Watching AI much closer to informal non-linear. Yeah. Honestly, like if it can actually generate like great stories one day, it'll be so awesome. But yeah, I'm not sure if you are there yet, quite yet. Okay, so now kind of like I mentioned these 3 tasks, but like first of all, why is like this task hard? Like we have all these key narratives of like characters and backgrounds. So why is like this even included as a task? Why is extracting all the characters like a non-trivial task? And the idea is that the characters in like detective novels and stuff might have like different identities, aliases at different points of the story. So the LLMs have a hard time like keeping track of this. Yeah. So that is like the first, why this first task is hard. Now, why it's like linking like relationships of each character to each other such a hard task? Like, if once we ignore this, why is it like this like father-son relationship and stuff hard? And this goes to like a pretty interesting paper called the reverse occurs LLM trained on A is B fails to learn B is A. And basically what the researchers found in this paper is like, once we ask, let's say we ask who is Tom Cruise's mother, then like GPT-4 at this time was able to answer Tom Cruise's mother is Mary Lee Peffier. Sorry if I mispronounced that. So this is correct. But once we ask like who is Mary Lee Peffier's son, it fails to know who like that the son is Tom Cruise. So when we kind of make this relationship, one thing that it fails to do is, even if it can identify that somebody is somebody's son and stuff, it fails to identify that somebody is somebody's father, So it can't do like the opposite thing. I don't know if this is solved yet, but at this point of when this paper was published, it's still a problem. Now, kind of like, finally, why is like inferring like hidden relationships hard? And kind of this goes back. I don't know if they kind of reference a specific paper for this, but one thing you'll know when you kind of prompt LLMs is if you include like contradictory information, the LLMs kind of have a bit of a struggle trying to solve that. So basically, kind of like, at least in detective novels, there's a lot of information that appear inconsistent because of like lies and like contradiction and things. So LLMs kind of have an issue trying to solve these kind of contradictions to come up with the answer, basically. Yeah. Okay. So now, kind of like one thing that I was thinking of when I was reading this paper is that kind of like, yeah, there is some contradiction in detective narratives, but like, isn't it like impossible to know what the correct like hidden relationships are? Or like, how can we kind of like conclusively know that let's say somebody's murder? Like, isn't there like couple possible answers there? And yeah, kind of like to answer that question, basically what the researchers did was they only evaluated LLMs based on like relationships that are without a doubt correct, basically. And the way they did this was they first kind of like got a bunch of detective narratives from from detective games. So basically they got a bunch of detective games, like 2,500 or so, and they got the background narratives. And then they kind of select the best 100 ones, and they ask like 3 like fans of those detective games to like label the character relationships. and only if like everybody agrees, it kind of like gets added to like the ground truth like dataset construction. Okay, so yeah, no, any question? Oh, yeah, it's kind of pretty crazy that such an easy task is hard to do. But yeah, so now kind of like the result is so it's a bit hard to read this, but basically altogether is like we try to immediately ask these LLMs like what is like the relationships of the graph and like the inferred relationships, like all of them all at once. And for corruption rate, it's like basically we can ignore it for now, but it's basically like how much the LLM was able to like, if it's 0, it means that the LLM was completely able to like output in the correct structure, like in the graphs and stuff. But if it's like higher, it means like it's kind of like made like invalid structures a lot. So you see that Llama 2 had a lot of invalid structures, but that is like besides the point. Firstly, altogether is like generating all the relationships all at once, and DIR relationship is like extracting characters from the narrative first. So like this first task first, and then kind of like utilizing the narratives along with those characters, we kind of like create the relationship network. And for the pair relationship, basically it's kind of like a way more complicated one where we first extract relationship, we include like relationships of each pair and like aggregated results and stuff. But I don't think this is too important because if we look at the F1 scores of pair relationships, it's consistently the worst. So I think like the researchers, at least from my perspective, I think the researchers made a mistake in this prompting direction. But for DLL relationship, I think it is correct because GPT-4 that's the best. But one interesting thing that I want to highlight here is for GPT-4, generating altogether is the best result. But overall, what I wanted to say was that it has terrible results. So F1 score is like best at 1, but the best LLM in the world was only able to get like 0.125, which is pretty bad. So another thing that I wanted to highlight a bit is this is just the results for just character extraction. And one thing we noticed is that the best F1 score came from like for all characters. For like single characters, GPT-4 that's okay, but for all characters, the best F1 score came from GPT 3.5, which I thought was pretty funny because GPT-4 is definitely way more capable than GPT 3.5, so I'm not sure why it has trouble here. So kind of like now the question is like why is this happening? Why is like these LLMs having like so much trouble generating relationships from these like complex relationships, these kind of like narratives and stuff? So one thing the researchers noticed was that around 20,000 characters, these are not tokens, these are characters, GPT-4 does pretty well. Like it has a 0.4 F1 score. Still not amazing, but it's still like pretty decent. But once we kind of reach this point, the F1 scores start declining steadily and steadily. Yeah, any questions? And the reason for this that the researchers referenced was a paper called Lost in the Middle, How Large Language Models Use Large Context. And one thing that the researchers of this paper found was that if we put, so this is like the how good the LLM is at finding like the word or finding like information given like the position in the prompt it is. So you notice that it's a bit like U-shaped, right? So what the researchers found was if we put information in the beginning and in the end of the prompt, the LLM pays attention, but in the middle, it kind of like pretty much ignores the information. So the idea for the researchers is like, if within these kind of characters, the LLM kind of like understands the full relationship and stuff. But once we kind of like extend it a bit too much, it only focuses on the beginning and the end. So like it kind of loses all the relationships in the middle. So it kind of like drops off like this. Yeah, does that make sense? Okay. So another kind of like measure of like how good LLMs are actually at like understanding stories is basically this kind of like this paper had an interesting idea of like let's have so LLMs kind of like pretty much read all the stories on the internet. At least that was kind of like an assumption. So why don't we have like writers write like private stories and like have it like shared with the researchers, and then let's ask like LLMs to summarize those stories. And one thing they found was that for like most of the LLMs, it had like a 50% success rate in like summarization, like containing all the correct facts and stuff, or like in Lama's case like 20%. So so the higher the better here. So basically, even in the best model for GPT-4, it only had a 56% rate of correctly summarizing according to the writers of those original stories. So it kind of like shows that the LLMs kind of have a bit of a lack of understanding of stories as a whole, in addition to like my previous point of like it can't generate complex stories correctly. Yeah. So the conclusion I have is that LLMs kind of as of now are not able to create stories that are like too complex, and also like it can't generate like certain stuff like suspense and stuff without like explicitly prompting for it in a way. But okay, now that that's out of the way, kind of like but now let's assume that the above issues are solved. Then the main issue becomes context length. So like, how can we generate a story that is outside of like GPT-4's context length? And for that, the first paper that kind of like approached this, actually this is not the first paper. It's an expansion on like another paper called RE3. But this paper approached this by giving an outline of like a story that you make. First, the LLM expands the outline, or the way like it kind of like adds a bunch of like events in the middle. Like for Sue flying to Italy, it adds like a step of like Sue packing up, and finally there is a final step of like a detailed controller, which kind of like expands on this to generate like an actual sentence like that. So yeah, this is like I saw this paper in a lot of references and stuff. And in like one of the previous papers where I talked about the outline, they used this technique to generate a story. So now kind of like how it actually works is honestly I noticed that a lot of papers are a bit similar to Globe in that given an event, it first kind of like expands that event by like adding like what happens next. So she flies to Italy, so the candidate is Sue goes home, Sue calls her agent, or Dave waves goodbye. And then the LLM selects Sue calls her agent, and with like something they call filtering and re-ranking. And then, it kind of like keeps expanding. But one of the main interesting thing that I found in a paper was that I think this is a bit due to like the previous case of like having trouble understanding like character relationships and character identities. But the paper explicitly asks for the settings and the characters at each and every single step. And also it explicitly asks the character developments at like each and every single step. So that's like one thing they did in outline expansion. And then after that, it's like just generating a story. Yeah, any questions for this? How much of the limitation is? How much of the limitation do you think is the priorities of foundational model companies? Being exposed to all these stories. Oh, I want to talk about a bit about like foundational modeling in stories a bit, but I think like these limitations are a bit more general limitations. In like I think there is a lot of focus now of trying to like having LLMs understand logical relationships, like graphical relationships, which current LLMs can't do, which I think is what is causing these limitations. Honestly, I'm kind of very interested in what the current state of like logic with LLMs are, because I think that might be a connection. But yeah, basically I'm saying like there is massive interest currently on having LLMs understand logic and having like correct answers, basically. Okay, so back to this. So before we move on, sorry. So before we move on, let's talk a bit about like what, because I will be talking a bit about training techniques of LLMs. Let me just talk a bit about how ChatGPT is made. So for how ChatGPT is made, first of all, we collect the data, and so we collect like bunch of like we collect bunch of like prompt data, and then we ask like a human labeler to generate the answer to each prompt, and then this is used to like fine tune like a LLM. So this stage is called pre-training, kind of. Actually, this is called supervised fine tuning, I guess. Sorry, this is called supervised fine tuning. I will talk about pre-training later. But once we kind of like collect like the data, we kind of like have a human kind of like say, we ask our LLM to generate the answers to a single prompt, and we have like a labeler like say like, oh, this answer is this answer is the best. And then we have like a reward model saying, trying to like replace that human, saying like, oh, kind of given these answers, this answer is the best and this answer is the worst, given the same prompt. So then the final step is we have this model which went through something called supervised fine tuning, and we have this reward model. So we make the LLM generate a story, and then we have this reward model keep giving back like saying like, oh, this story is good, this story is bad, which makes the model kind of like generate like more aligned stories. So that this is how ChatGPT was kind of made. And the kind of like recently there has been advances such as like Hugging Face's Zephyr model, where the basic idea is let's replace all these humans with GPT-4, basically. So given like a prompt, we have LLMs generate multi-party like interactions to kind of like making this supervised fine-tuning thing. And then we have like the AI like GPT-4 rank all the answers, and then we do something called like direct preference optimization to like make, basically it does the same thing as humans, but like, yeah, basically train the LLM to generate a certain answer of another. And one stage I forgot to mention is pre-training. And what pre-training is like given like a very huge data set of like, in our case, let's say stories, it basically tries to directly train on that to kind of given like all the previous tokens, predicting the next token over and over. Basically, that's like the whole gist of pre-training. And then we do this supervised fine-tuning and like reinforcement learning stage. Yeah. Any questions so far? Okay. So a bit more into like, so I kind of like briefly said DPO, which is direct preference optimization, but kind of like there wasn't like any mention of like this reward model thing. So the question is like, where did this go? Where did this reward model go? And the basic idea is what people found was we can just rank answers, and we don't have to have a reward model. And and what the people found was basically we can ignore this kind of like denominator, because basically what this is it's just setting the initial like this to 0. But the idea is let's have the LLM given like all the previous text. So this is given X is all the previous text. Try to generate a certain answer while discouraging it to answer in a different answer. So if this is ranked higher than this one, this is like a correct loss. So we're trying to make it like output a certain response over another response. That is like the entire idea behind DPO. Okay, so now that's out of the way. The main kind of like improvement on this doc paper was a paper from Facebook called End-to-End Plot Generator. And one thing they noticed was for doc, you have to like call the LLM so many times. Like for each outline step, we have to like message like OpenAI and stuff. So, which is like a very expensive thing for like normal people. And I guess in this case, even for Meta. So one thing they did was they replaced like the expensive OpenAI calls with a local LLM to generate the plots. So like Llama and stuff. And then once they get the plots and stuff, they did like supervised fine tuning so that you can kind of like generate these detailed plots in like one go, like way faster basically. So basically they did a bunch of training on these plots for like a certain LLM. So that it specialized in generating plots and making plots way faster. And yeah, and finally they did DPO to make it even better. Oh yeah, any questions? Oh, just one minute. Okay. So yeah, I talked a bit about plot generation, but the final paper I want to talk a bit about is foundational modeling. So the only foundational model, well, there was another one where it's kind of like fine-tuned for better results, but the main interesting foundational model I could find was one thing called Weaver. So it's a Weaver foundational models for creative writing. And basically, this paper I also found a bit interesting because they raise an interesting point in that in current LLMs, when you collect the data, like for the human crowd worker, what we are kind of like asking these human annotators to do is only to find helpful and harmless responses. And I guess recently it's also just like true responses. And what the authors argue is that asking like annotators to do this removes creativity. And also like another thing that they mentioned was a lot of these annotators are obviously not professional writers, so like they might not be like good enough for like writing creative stories or like generating those kinds of data. So yeah, so kind of like what they did was they created like a data set and they handled like all the pre-training, supervised fine-tuning and DPO and all that for like 4096 context length, I think. And they made like this suite of models called Weaver, which outperformed all these other models in the task of creative writing. So yeah, so actually I already explained this. This is like for you should actually it's important, so I'll just talk briefly again. Usually for like creating data, given like a prompt, we have like LLMs generate like questions and answers. So one thing that the researchers found was that in all these papers, all this like text that is generated, it's like most of it is like from LLMs. So like a lot of like high quality human original data is lost here. And also like all these LLM calls, but it's like way cheaper than asking humans to do it. It's still very expensive. So like, is there like ways to like make it cheaper but keep the high qualityness of the data. So that's the main question. So yeah, the supervised kind of is to not quote incorrect facts. Yeah. Basically, that's kind of like part of. Yeah, that is, I guess, part of like the reason. I guess kind of, yeah. I guess kind of annotators are incentivized to not include quotes, which in a way kind of like hinders the creative writing in a way. So yeah, that is an interesting point. I guess like annotators as of now are like kind of like have a motivation to not be as creative as possible, I guess. Yeah. So yeah. So kind of like now for how do we kind of like retain the creativity of the data while still kind of like making like an instruct data set. So an instruct data set is the data set that we use supervised fine tuning on. And the answer came from this paper called Long Form, Optimizing Instruction Tuning for Long Text Generation with Corpus Extraction. And the basic idea is we basically get a chunk of text from original high quality text data, and then we ask the LLM what's like an instruction to generate this piece of text, and that's pretty much it. And basically, kind of like the argument of the researchers is like we are asking LLM to generate like some high quality text like what humans generated, while only asking it to generate an instruction. So basically, it's like cheaper and cleaner to do this than like doing like what the Zephyr did and stuff. So yeah, and another kind of like few interesting facts is like the authors kind of like explicitly made it so that you use like you can use RAGs. Like usually like it's kind of just assumed that you can just plug in like context and that it works, but yes, researchers explicitly like added context during training to kind of like make it so that you can use RAGs and stuff. And also the researchers trained on like a function calling dataset. So yeah, kind of like I did mention like DPO. So basically we kind of prioritize a certain output over another. But kind of what they did was they did an improvement called constitutional DPO. And the basic idea is let's choose a domain in a task. So that let's say for creative non-fiction writing, let's choose a task of like polishing, editing, and brainstorming. Then they brought in human experts to like for each of these to write or like the principles or like what you have to abide by to like do these domains and tasks. So the content should be created to encourage readers to engage in interaction, comments, etc. So that's where the human experts come. Then they asked GPT-4. So they first of all, we already have like high quality data from here, and basically they did some filtering to like, I think they did like a bit of machine learning and also like human-based filtering to just get like the best kind of like instruction text pairs. Then what they did was they and this is like under the assumption that is those responses follow the principles, and which I think is true. Yeah. So they asked the GPT-4 like, given this prompt and instruction, how does this kind of like follow the principle well? Like, why is this a good quality data point? And then it asks like GPT-4 to, given this, how can we like modify the answer minimally so that it violates this principle? So now we have given this kind of GPT-4 helping out, we have a prompt and like a response that follows the principles, and a response that is a slight modification but doesn't follow the principles. And then what we can do is we can just do DPO. So yeah, any questions up to now? Okay. So that is like the main gist of this paper, and I think it's interesting. But I may have like two critiques. So first of all, the benchmark they have for here called Right Bench, I I tried going to the GitHub and I think it's currently offline. So yeah, there's no way to check this. But at least for the human evaluation part, like when they evaluate it versus humans, it seems to like consistently outperform like GPT-4 and stuff. But one of the more fundamental things that I'm kind of curious about is it's like basically this is a data set of only creative writing stuff, but like one thing I'm curious of is like, isn't like logic and like understanding, like maybe not understanding mathematics, but like understanding science and all those stuff like important for understanding like what is like good understanding of the stories and like the worlds around us. Kind of like I don't think that for like creative writing and stuff, a more generalist model like GPT-4 has a better chance of like understanding all those stuff rather than like a model specialized in like just writing creative stories, and where like all the data it's trained on is just creative stories. But I might honestly be wrong here. But yeah, the main conclusion that I wanted to drive home was that LLMs kind of like lack understanding of like complex relationships and stuff, and also it has like a forgetting in the middle problem, so it can't generate like very long stories as of now. And for like suspense and pacing and stuff, you have to like have specialized prompts to like resolve those issues. But currently there are like some foundational models to for like training LLMs for creative writing. But yeah, that's pretty much it. Thanks for listening. yeah, honestly I agree. Kind of like I think like understanding like graphs and stuff is so important for this. Oh, sorry. Okay. For Weber, it's not. I don't think it's fine tuned. Basically, they train it from scratch on like a Llama based model, I think. So and they do like pre-training. So like all their like knowledge of like logic and stuff is lost during the pre-training stage, I think. So yeah, I think that's a bit of a limitation. But thank you, Manuel. Yeah, I think like the foundational code is like Llama 2 and stuff, but not the model itself, I think. Okay. Yeah. I want to share my slides and stuff, and also a recording. I think I'm recorded this, so I can post it. Yeah, definitely. We'll send it out. Anyway, any last questions also? Okay. Well, thanks to everyone for attending this presentation. Oh, yes. Yeah, and for the next presentation, I think somebody is doing AlphaFold 3, which I'm pretty interested in. But yeah, so I think next week it'll be AlphaFold 3, and for next week we are not sure, but happy to invite anyone who wants to present. But yeah, overall, thanks for coming, and hope you all have a great day. We'll post like the recordings in a bit. Then, that's the last question. Oh yeah. So my previous recordings are on YouTube too. I have like a playlist of all the recordings so far, so I can share that too. And also, like, if you are interested, there's also a write-up that I shared, like a Medium article, where I also talked about some other papers, which might be of interest. Yeah. And like all all the write-ups and like recordings are like in GitHub repo, so you might be interested in that too. But yeah, overall, thanks for coming and that's a question. Awesome. Then thanks for coming and hope you